Hello everyone. So in this short video, we're going to be looking at AC Theory Level 1, Lesson 6. It deals with capacitive reactance in series and parallel. Now, the lesson that we're looking at is going to be working with capacitors that are in series and parallel. Now, about capacitance versus capacitive reactance. I want you guys to remember from the lecture in class that if we are talking capacitance, we are measuring it in farads, or F. Where if we are talking about capacitive reactance, that is the ohmic value that happens from capacitance, and it is measured still in ohms. So if you're measuring in ohms, all the laws of Ohm's law will apply to your circuit, whether it's in series or parallel. It's just like resistance in series and parallel. But if you're talking about capacitance in farads, the rules for series and parallel are flipped because of the formula for capacitive reactance, which is very similar to the formula for inductive reactance, but it is the reciprocal of 2 pi Fc, which that is why capacitance is kind of the opposite of what resistance is in series and parallel. And that's the basis of this lesson. So, to pick a problem that we could take a look at real quick to explain this, I chose question 5 on lesson 6 to begin with. Now, I've already answered this because this is take 2, but determine the total capacitance of this circuit. Because it's capacitance that they're asking for and it's a series circuit, we have to factor those capacitors with the reciprocal formula. And I want to give you guys a quick reminder of how to do that on the calculator. So our values were 2, 4, and 6 microfarads. I'm going to use microfarads to do this calculation. One of the tricky parts of capacitors is getting your decimal in the right spot and knowing when to do that. A lot of people have difficulty with when to convert from base units to micro, nano, or pico units. And what I say is if you have a hard time with that, always convert to your base unit. And you're going to have to add a lot of zeros and not lose count of those when you factor that in your calculator. But if you are getting the hang of that, you can factor a problem in micro units, and then as long as you're aware that you have to do your conversion after you do the equation. So let's take a quick look at adding a 2 microfarad, 4 microfarad, and 6 microfarad capacitor in series using the reciprocal formula. So I'm going to start off with the 2 microfarad capacitor after I turn on the calculator, make sure it's clear. So 2 microfarads, but then using the reciprocal formula, it's going to be the reciprocal of 2 plus the reciprocal of 4 plus the reciprocal of 6. And then I equal those out. And because I still have to reciprocal this to get the final answer, I hit the reciprocal button one more time and hit equals. And I get the answer that I showed you. It was 1.09 microfarads. And because I never converted out of microfarads, because that's what the question is asking, that is the answer to my problem. So if I jump ahead to question 7, where it starts bringing in the concept of voltage drop on series capacitors. Now, some people would try to relate this to a parallel circuit for voltage laws, but if we are in series, voltage drop is based upon the capacitive reactance, not the capacitance in farads. And this is where that reciprocal formula messes us up. So if we just want to know which capacitor has the largest voltage drop, well, you can see I already selected an answer on take 1 of this short video. And what I'd like to do is go ahead and prove this, that the lowest value capacitor is going to have more capacitive reactance than the higher value capacitor. So going over to our calculator, let me clear out what we have been working on before. Now what we're going to factor is our capacitive reactance formula. And again, real quick, capacitive reactance is equal to 2 pi FC reciprocal. So we're going to just pick a value of 60 for our frequency. So we'll go 60 hertz on this example and just plug that in. Now the capacitance is what we're going to change. Now this is going to get a little tricky because I'm not going to convert it to base units until the last step. So back to the calculator. If I do 2 pi frequency of 60 and then multiply that by 2 microfarads, I'm going to then hit the equals button, and because I still have to use the reciprocal, I hit the reciprocal key and enter. So I get this value here, which is much smaller than 1. It's 0.001326. Now because I used microfarads and the capacitive reactance formula is supposed to give me ohms, I then have to look at this and say I need to move my decimal point 6 spaces to get micro. So this would actually be 1,326.291 ohms of capacitive reactance. Okay? So then if I change this, so let's just write this down here real quick. If we say it is 1,326.291 ohms of capacitive reactance for a 2 microfarad capacitor, let's try the 6 microfarad capacitor. So same formula, 2 pi, I'm going to use a frequency of 60 hertz times 6. And I hit the equals button. So then I have to find the reciprocal again, and I get 0.00044297. Again, moving that decimal place point over 6 spaces again is going to give me 442.097. Ohms of capacitive reactance. So there we just proved to ourselves that the lower value capacitor actually is going to have a higher opposition to current flow because of the capacitive reactance in ohms, where the 6 microfarad capacitor has less resistance or opposition to current flow due to its capacitance being higher. So let's take a quick look at question 9. Now, this question is asking us again for capacitance. And as I've told you guys previously, the best thing to do is first of all write down what they're asking for. They're asking for capacitance, and I'm going to put T for total capacitance. And that is the question that they're asking us. And in this circuit, it looks like they have 4 capacitors, 2 of them, messed up on my capacitor symbol. Are in parallel, and then 2 are in series with that parallel branch. So we are actually on the wrong question. Sorry guys, let me jump forward. We should actually be looking at question 11. Apologies, I'm not going to redo. So back to the board. To factor these together, it's asking for total capacitance of this circuit, and you can utilize this back in question 9 now. So knowing that I have 2 in series, these 2 capacitors are simply going to get added together for the value in farads, because it's opposite of the rules of resistors in parallel. So they gave us a value of 4 and 8. So if I go ahead and combine 4 microfarads and 8 microfarads together, I get one capacitive value of 12 microfarads. And this is noting that it is 6 microfarads. And this one would be 8 microfarads. So once I have 3 capacitance values in series, I can go back to my calculator and factor this using the reciprocal formula. And I'll do that quick for you guys one more time too. So clear out your calculator, and we have 6, 8, and 12 microfarads. So if I go 6 reciprocal plus 8 reciprocal plus 12 reciprocal and find what that equals, hit the reciprocal button one more time and factor that, and I get 2.66. Now that is microfarads, and that is what they're asking us for in the question, is what is the total capacitance. So entering that into the question of 2.6, and it says 2 decimal places. So I'm going to go 2.67 and check it. And it's the correct answer. So that's just a quick reminder of how you factor both parallel and series. Now don't forget, once you figure out capacitance of a circuit, you then have to convert it into capacitive reactance. And that is what the whole next lesson is going to have you practice. So I'll see you in the next lesson, or I'll see you in class.